Hi, everybody. I'm Samantha, and I couldn't be more excited to be back in Boston. This past May, I had the opportunity to speak at the React Native Boston meetup, and everybody was just so awesome, and so I'm really glad to be back in Boston. So I'm going to be talking to you guys about, talking to y'all about, let's be correct, about going from sketch to code and how my previous team at MLS designed our component kit. Okay, so I'm Samantha, and I'm a software engineer at MailChimp. I used to work at Major League Soccer, where I helped launch a React Native app using React Native, of course, and GraphQL. I also like to build small furniture. Here's a photo of me working on a 12-foot-long desk, so yes, very, very small. Yeah, and I also like to play football. Flag football, in fact. Here's my team. We won second place, and it was really, really fun to play outdoors. So be active, y'all. Sorry, I have to use two computers. So now that you know way too much about me, let's figure out what we're going to be talking about today. It's going to be mostly me talking at you with a little bit of audience participation, so bear with me. So let's talk about why we're talking about components. Then we're going to go into what makes a component. Why is a component kit necessary? How designers and Storybook contributes to making a good kit. And then we're going to put all that together from what we learned today. But I also wanted to point out there are two types of components you can make, a universal or a shared component. At first I was kind of confused what the difference was, so I just want to make sure that's clear with everybody else. So universal components can be rendered on any platform, mobile, web, VR, etc., using the same exact code. In my opinion, it's a little bit more experimental, but it's definitely something you can do. And a shared component is when components are used across multiple different projects within the app. This talk will be mostly focused on shared components, but a lot of the key points that we talk about today can be used for both universal and shared. Okay, so why are we talking about components? The idea of creating a shared library of components is an easy concept for everybody to understand. But the difficulty we will soon find out is how to decide what components to create. But I broke it down into 5 key points of why we should start building out components. So the first thing is because technology is changing, and so should we. We have a lot of technologies that weren't available before, like React, which was designed to be like reusable Lego block pieces for your UI. So we don't need to copy and paste anymore. The old way of doing things is not scalable. And I don't know about you, but I don't want to go across multiple projects changing the same exact code. Which brings me to my next point. Wouldn't it be nice to write less code and to work less as an individual contributor? Well, with components, that's an option. I could be a little bit lazy sometimes. Yes, I am human. So when I grab a ticket to build out a screen, I get pumped. Because when you have a component-based system in place, I get to focus on pulling and manipulating data and not this other thing called CSS. So I'm pretty much stack the components next to each other and plug in some data, and I'm done. Everything you might have enjoyed when you were younger playing with Lego blocks is true when you get older, except the stepping on them part. So managing projects become more efficient. We are no longer copying and pasting, our code base gets reduced, and our actual files get smaller. When updates need to happen, they update on the component level. They update across multiple apps and projects. And if you didn't duplicate any components, you'll just have to update it in one place. Isn't that unbelievable? Yeah. So, you know what else is unbelievable? When you can isolate bugs. No more guessing if the component is causing the problem, because you know it's not going to do that. Your component is going to be well tested, and we're going to talk about testing a little bit later, but we also can eliminate the component being the problem. So if you find a bug, it's not the component's fault, it's a you problem. And lastly, we're going to talk about components because we want to have a consistent UX across all apps and projects. Now, I want to mention there are pre-packaged component libraries out there. There's some awesome ones like Material UI and Semantic. So why don't companies use those more often? Well, it's a simple answer. because of branding. We all want to stand out. But when dealing with brands, we also have an additional work layer. The lead designer from Airbnb had this quote: "Software is often built by incredibly large teams of people. The challenge of creating coherent experiences multiplies exponentially as more people are added to the mix. Over time, no matter how consistent or small your team is, different people will contribute new solutions and styles, causing experience to diverge." So, the more inconsistent the user experience is, the slower production development becomes, and vice versa. So now that you know why components are extremely impressive, now let's figure out what makes a component. The first thing it needs to do is be reusable. That means they can be extended, allowing you to easily create new components from existing ones. It also needs to be composable. It can be combined with other components together to create new experiences, and it needs to be encapsulated. So you have isolated markup, isolated styles, isolated behavior. So that's a textbook definition of what a component is made out of. But after doing some work with them for a while, I've come up with some other tips that we can use. So they need to be static. They're like your app's primitives. The only task they should have is to render data. So whatever means necessary, do not allow that component to fetch its own data, because you never know where that component is going to live within the application or how the developer would use it. And if you have similar APIs, so if you have similar components, you should have similar APIs. So there's a card on the left and a list item on the right. At MLS, these two components were actually built by two different developers, which led to different naming prop conventions. The card component had image URI prop, and the list item had an image prop. It seems small, but these components, as the component kit got larger, this became a huge problem. And it actually took me a lot of time to memorize the API. Then when working with React and React Native, dealing with iOS and Android, for some odd reason, they didn't like playing with each other. They were like the Sour Patch Kids. So adding margin or height in one worked, but the other one, it didn't quite look right. So we need a way to handle those darn kids, right? And it can be really hard to override these styles that are embedded, but allowing the app to control the bounding box of the component is a start. Then we need to make sure that every component is discoverable. If we can't find it, people are not going to use it. So we need to have a complete list of every single component. And ideally, each component should be detailed displayed in every state. And let's not forget to document our props and our types and how to use them. So when we first began building our Greenfield app at MLS, the app decided what state to render. The app would be able to use card with data and card with no data, but it became a little unnecessary. So we put the weight on the component itself to determine what state, so that way we had less boilerplate code in the actual application. So on the code on the screen, you'll see this code will actually live inside of the component folder. And based on the properties that you were passed, it would determine what states to render. Like if there was data, it would render the card tile, and if there's no data, it would render a no data tile. And then we need to treat our components like a third-party library, as if you were going to open source it. Generally, when something is open source, it is well tested, well documented, versioned, and well maintained. And the last tip I have is that components are great, let's not get me wrong, but if you need to put a limit on which ones you're going to make. Forcing everything to be a component makes it a lot harder to maintain. And if you're only going to use it 1 or 2 times, then there may not be a need for the component to be in the library. So that brings me to my next point. How do you know to make something a component? And in true fashion, I have some tips for you, but in a checklist form. If you could easily apply the change with a modifier, then it's the same component. If it requires a lot of changes, then you probably need to make a new component. So you need to ask yourself, if the appearance of X on component A do we expect the appearance of X on a component B and C to be the same? If not, they're not the same component. Again, we have to figure out how often the component needs to be used. If it's a one-off for design, then it's probably not a component. And when you need to give it abstract names, avoiding stuff like search result snippet and just use snippet. Ba-ba-ba-ba! Game time. So I don't have a demo, but I do have a game. This is where the audience participation happens. And I can see you guys in the back, so you guys have to play too. So I don't need you guys to raise your hands. Just a little bit of this or a little bit of that will work perfect for me. So we're going to play component or nah. All right. So we have a few buttons here. Do you guys think these are components or nah? Okay, everybody thinks it's yes, but if you look closely at the code, there's no way for us to kind of override the styles on this. We're kind of stuck with these buttons the way they are. So it kind of becomes useless when we have to reposition them. So I would say this is a nah. Okay. Then, let's see here. Okay, so we have the buttons again. There's a lot more code here, so this has to work because there's more code, right? So what do you guys think, component or nah? Okay, yes, everybody got that right. Okay. So the button is actually fetching its own data, so it becomes useless because what if we want to, down the line, change our API from maybe a RESTful to a GraphQL, because you guys saw how awesome GraphQL was earlier. And then, so we have a nah. Okay, all right, y'all are doing great. So this one's a little bit more trickier. So design doesn't really like component A, and they wanted to change it to make it look like component B. Is this the same component? People are saying no? Oh, it's too different. Okay, but the design wants to change it. Like, they don't want the old design anymore. So you can reuse that same component and make it the newer one. And then that's it. So everybody's a winner today. All right. So after the speech, we all get to have lunch. So enjoy your lunch. So yay, it's a component. Okay. So enough fun and games. Let's talk about why a component kit is necessary. So the first thing is it's because of organization. People need to be able to see your component and what is available. They should be able to browse your kit in a meaningful manner, identify the components, and understand the hierarchy which they live in. Then we have communication. By approaching product development like Lego blocks, we get more time back to focus on the bigger development problems. We minimize the redundant conversations and the one-off solutions. And remember earlier when I was talking about the textbook definition of reusability? Well, it's just not for code. The process of reusability touches every stage of development on every single level. And then we have faster development. Reusable components help your team move faster by creating high-level abstractions. Components eliminate decision fatigue, enforcing a standard approach. Okay. So here's this card again that people don't agree is a component, but it is. Okay. So we no longer have to focus on the following decisions. Like every time, we don't have to worry about, do I put the date on top or the bottom of the title? Do I need to center align or left align the text? Or how much padding do I need? Those little decisions add up, and components help us eliminate those decisions every single time. And then we have performance. Actually, the coolest thing about components is that they actually minimize the application's bundle size. Using a component a second time doesn't actually require an additional download. And without a kit, like another developer will actually probably duplicate the JavaScript, causing the same problems in a different way. And even worse, developers could actually grab a competing library and making the users actually download more stuff, and we don't want that. So how do we start building a kit? That's why we're here today, to figure that out. So to start off, we need to have a design system. So it's not technically a style guide or a pattern library, but it's pretty close. Building and maintaining a style design system is definitely a huge challenge, but overall one worth facing. It can help break your teams out of a vicious cycle of unscalable design. The design system is a true gold standard, but it's not set in stone and should evolve as your product and grows and always reflect the truth. That way, we don't have any user confusion. Different design patterns responsible for the same action actually causes user confusion. We don't have a slow design process because now designers can actually reuse the same things and not building everything from scratch. And we actually have a better time with onboarding since new designers and engineers can use a documented system. On this slide, you'll see different things that in the design system, like color palettes and design principles and icon. Now that we have a design system, we need to make a handoff tool so designers can communicate with engineers. And of course, I have another list in choosing the right tool for your team. Okay, here they come. So we need to create easily shareable outputs. That way, the engineers don't have to wait for design to give them assets. They could just get them on the spot. It needs to be able to generate and display specs. It needs to sync with designs and make sure they're always updated. At MLS, we consider our designs a source of truth. It can be challenging when discussions about design are made in Jira or in a Slack conversation, but we always need to have a note on the handoff tool about final decisions. And we also need to distinguish between properties like fonts and colors, assets, and parameters. So after looking at all the requirements that we needed in a handoff tool, we decided to use Zeppelin. It's a tool where engineers can see design in code. It's great for both designers because it has a plugin for Sketch, which allows them to quickly update the designs. It's also perfect for engineers because there's an extension for React Native, so we could copy the CSS. And there's a lot of room for communication about Zeppelin. We can add comments to files and just discuss things that are updating. And each Zeppelin file has its own link, so it can be attached to your Jira ticket. So now we need to make a code implementation of our design system. And that way we can reduce code and save time during development. You can think of this as a living style guide. And we chose Storybook, but there's other options like DocZ and Style Guidance. But for us, Storybook was a great way for us to display our components. With Storybook, we're able to complete the whole lifecycle of a component. We are able to develop and design, show documentation, and have discussions and solve bugs in one place. There are a lot of talks about Storybook.js, so I'm not going to go over that. But pretty much you write stories in JS, and then the magic happens. You can see different states. Developers can quickly grab a story and place it within their projects. And we're able to use documentation. My favorite add-on that they have in Storybook is the width info, and it automatically updates all your types for you, so you don't have to keep up with that. And I also recommend using real data in your stories, because then design cannot do an accurate visual QA if you're using random images. So we hooked up our Storybook to our GraphQL client. The best thing about Storybook is it allows you to develop in isolation. As you see in the slide, I have an example of a component in the app and an example of a component in the Storybook. In order for me to get to this component in the app, I have to wait for the app to load. Then I have to click on a tab, and I have to wait for that tab to load, just to get to that component to see what changes I made. What a pain. But since Storybook is so fast with its hot reloading, I could develop this component in half the time as I did it if I was in the app. And this blessing in disguise is it splits up the complexity of the components based on your skill level. As you see here, this is my first component that I made on the job. And I would love to continue to tell you how great Storybook is, but there's also a lightning talk after lunch presented by Aaron Fox, who will be telling us her story about Storybook and as a junior engineer. So I'm really looking forward to hearing about that. So now that we have Storybook and we have Zeppelin, let's see how we could put those two things together. The first thing I would say is communication. It's the foundation, it's your glue. We need all teams, design, product, engineering, QA, to be on the same page when it comes to components, or it would be a hot mess. The product team needs to make tickets in Jira, picture, and the QA team needs to make tests in isolation. So since we're on the topic of communication, I would like to make a public service announcement, so listen up. Everybody's perspective on your team is very, very important. So please allow women to speak. We have tons of ideas, and we find it very, very hard to talk over men when they're talking over each other. We have things to say. I have things to say. Look at me, I'm on the stage telling my story, right? So amplify us when we have ideas, good or bad, because it'll make the whole team stronger. And ladies, command the room. Don't play their game and speak over them, all right? Say, I have something to say, and everybody will quiet down. Say what you have to say, because you belong in that room too. That's my public service announcement. Thank you. Thank you. All right. So, this two-computer thing is not working. So here is a visual of how the teams actually work. This is my interpretation. So step one of building a component kit starts with your stakeholders and your product team and design. They come together and kind of brainstorm what the user needs as well as the business goals. I'm not really sure how they communicate with each other, but I feel like it goes a little bit like this, like a little scribble scrabble. And then us engineers are just over there waiting on the side. So overall, all three parties understand that there needs to be a design system, and we need to create components that can be reused. Because they, too, are worried about consistency, quality, speed to market, and maintenance. Okay. So after these three parties communicate, a component is revealed. Here you see on the slide, you see different states of the match tile and how they can be used. Like we have pre-match, we have live match, and we have post-match. And now on the screen, you'll see these little tiny notes, these little tiny yellow dots, and they're notes. And we actually use these dots for our communication to keep us source of truth. And then we became a little bit more productive, and we built a grid system that anybody could update the functionality of the components. And of course, we put all this in our handoff tool, Zeppelin, and so engineers can start working. So how do designers and engineers really work together? Well, the ideal way would be the throw it over the fence method. In this diagram, you can see that the designers took a concept from idea and created detailed designs, and all the things that could go wrong magically were figured out before handing off. Then the engineers can pick up the designs with no questions at all, for some odd reason, no questions, and they build it. Then the design comes back and looks at the build and approves everything on the first go, then ships it. Wouldn't that be spectacular? Yeah, but we all know this doesn't happen. It's a fantasy. So here's a more realistic way of working, is one team, not two method. The design team still starts to work on their own, but the key difference is they engage with the engineering team a lot earlier in the process. This gives them earlier tech feedback, and it gives the engineering team earlier exposure to their upcoming work. And for me personally, I love this method. Seeing the work earlier keeps me excited and inspired. And being involved early on in the process confirms the why of the company to me. Well, I don't really know who truly enjoys meetings, but like adding one more meeting shouldn't really hurt, right? But for me, having that 30-minute to an hour conversation early on about the future, about what's coming up, It's kind of crucial to the team's culture. And you need to invite everybody, not just the leads. Just take that moment to explain to me why this new feature is important. That way, I feel like I'm tackling the problem with you. And it keeps me, of course, motivated. And shoot, I could tell the designers, hey, we can't do that because the technical blah, 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 blah doesn't work. And we can meet those lovely deadlines. So we also came up with this thing called a design system committee. While everybody on the team should understand what is a component kit, having a few people on a team as the main maintainer is a great idea. And these people should also rotate as well. It's a way to create continuous conversation about what components go in the kit. They make sure they have a consistent API, and just makes the workflow a little bit easier. So I'm going to give you guys a lovely wrap down of what the component kit lifecycle is from what you guys learned today. So we start off with a design system. And then from there, we create a themed file. This will include all your colors, your font sizes, your padding. And at the same time, design is using Sketch to make their lovely masterpieces. And then we send them all over to Zeppelin. And then the engineers use Zeppelin to create components in Storybook. Pretty straightforward so far, right? Then we have this next section here, and I'll go over it just a little bit slower. From Storybook, a PR is made. Then we make a link so we can send it to the design team. Then the component goes to a visual QA, and it gets approved or unapproved. And if it doesn't pass QA, then we have to send it back. We have to make a JIRA ticket, and we have to send it back to Storybook. That's a lot of work, and we don't want to keep doing this feedback loop, especially when it's something unavoidable like design. So, like in true tech presentation fashion, I'm going to introduce all you guys to version 3.4 of pairing with designers. OK, that joke didn't go well. OK. So we came up with this idea of pairing with designers. If you didn't notice, there's a lot less arrows and a lot less junk, because our designers were like, if you need something, we are always there for you. And since we have these things called open offices, we might as well talk to each other. And it's a great way for us to collaborate. These pairings with the designer can range from anywhere between 5 to 30 minutes, depending on what the engineering needs or what the ticket entails on the design and UX front. We found this to be a huge improvement on the workflow. So we got rid of that nasty feedback loop of PR, JIRA ticket, visual QA, and we are now pairing with designers. So then it goes to the Storybook, and QA does their thing. And then we have an award-winning component. That's it. Thank you guys so much.